Problem number 2. When the 6-digit number 3, 4, 5, 6, and 7 is divided by 8, the remainder is 5. List both possible values for the digit n. Alright. Well, the first thing to recognize is that when you divide this number by 8, you have 5 left over, which means that if we were to take those 5 that would be left over and take them away, we should have a number that's evenly divisible by 8. Alright? So what I'm saying is that 3, 4, 5, 6, and 7 minus 5 is divisible by 8. Okay? Does that make sense? Because you know that when you divide this number by 8, you have 5 left over. So if you were to take that 5 that's left over and just get rid of it, take it away initially, then you should have something that's evenly divisible by 8. Okay, so if we do that, 3, 4, 5, 6, and 2 is divisible by 8. Alright? So now we can just use our divisibility rules. And the divisibility rule for 8 is that we just need to look at the last 3 numbers. Okay? Because 1,000, this is, well, here I could write this out in expanded form. And I could write this as 3 times 100,000, right? Plus 4 times 10,000 plus 5 times 1,000 plus 6 times 100 plus n times 10 plus 2. Okay, and you can see that 100,000 is divisible by 8, right? 10,000 is divisible by 8. 1,000 is divisible by 8, but 100 is not, right? Because 1,000 is 125 when you divide it by 8, but 100 you can't divide that by 8 evenly. So if this number represented here is divisible by 8, then the whole thing is divisible by 8, right? Because these 300,000, 40,000, and 50 or 5,000 are automatically divisible by 8. All right. So let's look at just those last numbers. Okay. So we can just look at 6n2 and divide it by 8 and see what we get. You may be asking, well, we don't know n. So, well, let's look at a couple of different cases. One is where n is greater than 4. Okay, so let's look at that case first. Because we know if n is greater than 4, we would just take 8 times 8 and get 64, right? And put that down here. And then we'd subtract, and if n is greater than 4, that will subtract evenly, and then we'll have something ending in a 2. And you know, the multiples of 8 look like 8, 16, 24, 32, 40, 48, and we have 56, 64, 72, 80, okay? And there's 2 of them that end in 2. Alright, so we have 32 or we have 72, okay? So this number here, in order for this to be evenly divisible by 8, would have to be a 3, right? Because if it was 7, then n would have n would have to be 11, and that's not a digit. So so this would have to be 32, which means that n would have to be 7, right? Now let's look at the other case. If n was less than 4, alright, then we divide 8 into 6 n2. Let's see. I'll make myself a little more room here. Hopefully that doesn't get messy. Anyway, so So then we would use a 7, right? And we'd get 56. And then we'd take 60 something, subtract out 56, and we get something 2, right? So here we would have to borrow because n is less than 4. So this would be like 10 plus n. And you could see that the only thing ending in 2 that will work is 7, right? Because then that would give us 13 here when we borrow. So this would become 5, right? So 13 minus 6 is 7. And you can see the n would have to be 3. All right? So even though we didn't know n, we can pretend like we did and see what we would do in different cases. So we did a case for for n greater than 4 and n less than 4. And we found the two values for n. So n can be 7 or n can be 3. Okay? And there you go, that's the answer.